If you're like me, then you've wanted a milling machine for years. You've watched YouTube's greatest machinists do their thing, and you want to join the club. You've scoured your local marketplace and have watched several deals come and gone, never quite able to pull the trigger. Not because you can't afford it, but because you have no idea how to get it home. The general consensus is that in order to move a milling machine or any kind of machinery, you're going to need a pickup truck and preferably some sort of car trailer or a trailer that has a flat bed that you can put like 10,000 pounds on it. Well, I don't have either of those things, and yet I was able to move my mill. So let me show you how I did it. Okay, before I continue, I must give this warning. The techniques demonstrated in this video are for educational purposes only. I do not endorse attempting these methods without proper training, equipment, or supervision. Moving heavy loads can be extremely dangerous and may result in serious injury or death. You are solely responsible for assessing the risks and taking all necessary precautions. Proceed at your own risk. Okay, with that out of the way, let's start with my tow vehicle. I own a 2003 Toyota RAV4 two-wheel drive. It's definitely not what you consider a tow vehicle, but for me, it got the job done. As for the trailer, I rented this specific trailer from a specific company that has an orange logo. And the reason I opted for this version is because it has a ramp. And the most important part for me is that it boasts about 3,700 pounds of cargo capacity and includes surge brakes. So I estimated that the mill I'll be purchasing at most will weigh 3,500 pounds. 3,700 pound max payload for the trailer will definitely cover that. After that, the biggest problem is how do you stop? With all that weight and all that mass and all that momentum, the only way to stop is with surge brakes. So having surge brakes on the trailer means I can come to a stop safely when I need to. Some of the other tools that you'll see me using to unload the mill is I have two different pry bars that I use. I'm using a floor jack, preferably a low profile floor jack. I have a bunch of jack stands, a come along, and uh, something that's kind of important is having sort of these wooden blocks. They're essentially just 2x4s cut into 12-inch sections that I use as cribbing. And you're going to want probably 8 pieces of those. And then what you can do is take some of those 12-inch sections, cut them diagonally across to make a wedge shape to make sort of wheel chocks. And you're going to want about, 4 to 6 pieces of those in order to stop the mill from rolling once it's on an incline. To get the mill rolling, what you're going to want to do is essentially bolt on 4 of these heavy duty casters on the mill. The ones I'm showing, I made them myself. I cannot take credit for their design or usage. I actually saw another YouTuber, essentially make them and use them to roll around really heavy machinery, and that's how I got the inspiration. I cannot for the life of me remember who that was, but I definitely did not come up with it. To make the machine casters, I took these phenolic wheels. They're about 5 inches in diameter, 2 inches thick, with a half-inch bore. So I essentially used a half 13 bolt as the axle, welded them to some 2.5-inch angle iron that are about 7 inches to 9 inches long. And then this is what one of those machine casters would look like is you have the phenolic wheel, 2.5-inch angle iron, the half 13 bolt that's acting as an axle. You just sort of, weld the two pieces together. Then I just used, these are half-inch inner diameter bushings with if you can find them with a 1 inch outer diameter, that's great. If you can't, I think you can find them with a 3/4 or 5/8 outer diameter. These aren't super critically important, But imagine if you have two of these opposing each other, these caster wheels, these bushings allow you to essentially run a half 13 all thread, and then you cap it off with a nut on either side, then you're kind of good to go. The only other thing is ensuring that you have a washer on the inside and on the outside of this wheel so that it's able to rotate freely, with a little bit of space between this angle iron. So just to clarify, the point of the all thread with the nuts on the end is to tightly clamp two of the casters on either side of the machine. The unloading technique that I'm going to show can also be done in reverse to load a machine onto a trailer. That's how I was able to bring home my lathe. However, I kind of lucked out. The seller that I got this milling machine from, they have a giant forklift, so they were able to just lift the whole thing and load it in the back of the trailer, and got that all done within a matter of minutes, really. But when I first started to strap down the machine, I made sure to turn the head around and then butt the knee up against the motor along with a piece of cardboard so I don't damage any paint or scratch anything. The reason to have the table support the head is that the tilt and yaw mechanism of a milling machine tends to be a little bit weaker, and so I didn't want to risk having either of those mechanisms break during transit if I hit a pothole, for example. So I've sped this clip up, but what you see me doing here is I'm using those pry bars that I have to pry the machine up, and I am sliding those 2x4 wedges that we cut under the machine a little bit at a time. I'm only lifting the machine less than a centimeter at a time. I did the front, and then I come to the back, and then I do the front, I come to the back. Sometimes I do one corner at a time. Sometimes I try to do both corners if I'm feeling a little frisky. But the thing is, it's amazing, to think that I'm 5'8". I weigh about 150 pounds, but 150 pounds at the end of a 2.5-foot long pry bar, you can really get a lot of leverage to lift essentially a 3,000-pound machine. And before we get too far along with trying to get the mill off the trailer, I remember to put jack stands in the rear corners of the trailer. Make sure when you put the jack stands underneath the trailer that you actually support it from a cross member or some sort of structural member. And the reason we do this is because eventually we're going to have 3,000, 3,500 pounds sort of cantilevering on the rear lip of that trailer. And the only thing that's keeping us from tipping over is the ball hitch. And so any little bit of extra insurance to ensure that things go smoothly and that you don't hurt yourself is pretty good. So I'm just going through, working the mill little by little, raising it up, again, less than a centimeter at a time. I go to the front, raise it up half a centimeter, come to the back, raise it up half a centimeter, and eventually you do see me realize that, oh, wait, hold on a second. We're starting to get towards what I consider the danger zone. I'm working on a driveway, which means it's sloped. So the driveway is sloped towards the road. And as I'm lifting, I'm prying on the rear of the mill, I realize, wow, this is actually a lot easier than prying on the front of the mill. So I decided that maybe it would be best if we throw a ratchet strap around sort of the ram and ratchet strap it to the back of the trailer to prevent it from tipping forward and, again, damaging something, hurting something, killing me, and or getting myself into a situation that I can't sort of fix. So as I start to elevate the mill more and more, I'm starting to get closer to installing those casters and rolling the mill off of the trailer. And earlier, when I put the jack stands underneath the trailer, I just sort of rested them against the structural member. But now what I want is for the rear of the trailer to fully rest its full weight on the jack stand. So in order to do that, what I'm going to have to do is use the hydraulic jack to lift the trailer up so I can extend the jack stands and then lower the trailer's full weight onto each of the jack stands. Eventually, the mill is so elevated that I can even get my low profile jack underneath to just jack it up, put more 2x4s underneath it, go to the front, do the same thing, come to the back, do the same thing, and before I know it, it's high enough for me to install those casters. I finally got the casters installed, and the mill is rolling on its own. You can see that right now I'm actually using the ratchet straps to pull the mill back towards the rear of the trailer because, again, due to the incline of my driveway, now that 3,000 to 3,500 pounds is free to roll, it wants to roll all the way forward to the front of the trailer. So the only way I can get it to the back is by using the ratchet straps. Or I guess I could have tried pushing it with all of my might, but the ratchet strap seemed easier and simpler and safer. So here is a closer look from the rear as I'm working the mill closer and closer towards the rear of the trailer. And at the front of the mill, I actually have pieces of timber, 2x4, 4x4s, just long pieces to sort of wedge in front of the mill as I pull it back. What this does is, just in case the ratchet straps fail for any reason, the mill can only roll forward about an inch, maybe 2 inches before it hits a hard stop. And this way it has no chance to build up any sort of momentum. Once you get to this point, which is sort of like the tipping point with the mill, you're not sure when the mill is going to change its mind about wanting to roll forward to wanting to start rolling backwards into the garage. What I've done now is I've got the come along attached to the front of the mill, and I have these long ratchet straps pulling it back. So what I'm doing is I'm tensioning the come along just enough so that the ratchet straps can sort of pull the mill back an inch or two before the come along sort of prevents it from moving any further. And then I am going to the front, loosening the come along maybe 1 or 2 ratchet teeth, and then tightening the ratchet straps at the back 1 or 2 teeth. And just, again, it's a very slow, methodical process. You're just working it front, 1 teeth at a time, come to the back, 1 teeth at a time, or 1 tooth at a time, go to the front, 1 tooth at a time, and repeat. Once I get close enough to the ramp, I decided to put some pine boards down because you can see that ramp is basically just all mesh. I think it's some sort of aluminum mesh. And, I just didn't really trust it. I have, 4 casters that are 2 inches wide. And so, you have upwards of 3,500 pounds all concentrated on these 4 tiny little contact patches. So I decided let's spread that out a little and put a pine board down, just so I don't break the mesh or sink through the mesh or what have you. Here's what the front of the whole operation looks like. You can see that I have a come along, and it's actually attached to 2 ratchet straps to the front of the trailer. The reason for that is because my come along is actually not long enough to completely lower the mill into the garage. So it was a very arduous process of having to, get to the edge, sort of get to the limit of the travel of my come along, and then having to use the yellow ratchet straps to sort of strap the mill in to prevent it from moving. Also using the wheel chocks, and then what I can do is, loosen the come along, so that I can add in ratchet straps and then, lower the mill, then have secure it with more ratchet straps so I can, lengthen the black ratchet straps and so forth, and on just on repeat ad infinitum. And if we take a closer look at the way the come along is attached to the mill, you can see that it's attached to the mill via a lifting strap at the base, but also there is a black ratchet strap that sort of goes up and over around the ram. The reason I added that was because as the mill started tipping, into the garage and onto the ramp, I thought to myself, ooh, it would be really, really bad if the mill just tipped over. So I thought, again, I have the ratchet straps, it's insurance, let's use it. So yeah, this is a very arduous process. Slow and steady wins the race. Um, these footages are completely sped up, like 1,000%, 500%. Um, it took me forever, essentially. Um, and you'll also see that like anytime I need to walk around the back of the mill, which is the direction that it would want to roll in, I don't dawdle, right? If I need to walk around the back of the mill, then I get around it as quickly as I can, right? Otherwise, I try to go through the front of the mill, and you know, towards the back of my garage, I've got things cleared away. So, on the off chance the chocks don't work, the come along explodes, the ratchet straps vaporizes, then oh well, the mill will roll into my garage, and I'm just gonna let it go. I'm not gonna try to catch it. This is again 3,000 pounds of cast iron. Once it builds momentum, you're not stopping it. So be careful. Another thing is I do not stick any part of myself underneath the mill for any reason. So even while I was lifting it and installing those casters, I was keeping my hands to the side of the mill. And if, for example, a nut or a bolt rolls underneath the mill, I fight that urge to want to reach in and try to grab it right away. Instead, I go and pick up my pry bar and I use it to fish it back out. Because, again, 3,000 pounds. If it lands on you, on any part of your limbs, it's gone. So, be careful. And, of course, eventually, terra firma, baby! Okay, so at the end, this is what you end up with. Make sure you chock the wheels, and hopefully it doesn't go anywhere. So that's it. That's how you unload a mill from start to finish. And if you ever need to load a mill, then just do the aforementioned steps in reverse. A couple of notes. So my Toyota RAV4, it towed the trailer with the mill in it handsomely. I wouldn't say comfortably. I was completely ready to burn out my transmission, to blow up the engine, maybe. But none of that happened. Um, it was a bit of a bear to try to maintain speed on a slight incline, but I made sure to, uh, you know, always, always stay in the rightmost lane. And if I know I'm going into a sort of windy section of the road, what I did was I kind of pulled over and let other people pass me, just because I didn't want anybody to have to tailgate me. All the people out there tailgating somebody towing a very heavy load, like they really have no idea how dangerous that is. Um, Another thing was I did not take any interstates. I didn't take any highways. Um, I just took, you know, I just took back roads, county roads, and all that kind of stuff. I'd rather make it home in 4 hours than not make it home at all, essentially. And the whole process is just slow and steady, right? You go slow, you do it methodically, and you will be successful. If you don't, then you will die because this is a very heavy thing. This is a very dangerous thing. Um, I really would not recommend anybody else do this unless they really, really know what they're doing. I do not condone any of the techniques I showed. I'm just documenting it to let people know that it worked for me. Um, so I do not endorse this. Attempt to do similar things at your own risk. And thank you for watching.